last episode of the GeoTrek podcast, we heard the story behind Buffalo, New York's deadliest blizzard on record. The Christmas week blizzard of 2022 inflicted 44 fatalities on a region normally accustomed to cold weather and heavy snow. In that podcast, meteorologist Don Paul talked about how changes in the polar vortex can lead to Arctic weather outbreaks in the United States, and referenced the work done by Cohen for understanding how these patterns work. Hey everyone, I'm Dr. Hal, host of the GeoTrek podcast. Welcome to GeoTrek podcast number 64, which is a companion episode to the last one. In this episode, Cohen comes on the podcast to explain the science behind extreme weather outbreaks in more detail. Dr. Cohen is a climatologist working at MIT in Boston. If you're new to the podcast, GeoTrek investigates the impact of extreme weather and natural disasters on individuals and communities. Our goal is to help you improve your decision-making, risk assessment, and communication related to extreme events, so you can take action to make yourself, your family, and your community more resilient. A quick favor to ask you, we would really appreciate if you would share this podcast with one person impacted by extremely cold temperatures. Could be a professional connection, maybe someone that's an insurance professional who handles damage claims from frozen pipes or things like that. Or it could be your favorite aunt who loves gardening and is threatened by extreme cold in the winter with threats of freezing her garden outside her home. We wanted to focus again on Arctic weather outbreaks because this topic is so important, as this phenomenon has inflicted catastrophic losses in recent years. Take the 2021 Texas freeze, for example. According to the Houston Chronicle, that event inflicted 246 fatalities, according to official government records, and as many as 700 fatalities when including excess deaths, according to a study by BuzzFeed. The cost on the Texas economy was estimated at $130 billion. Again, this isn't a hurricane. This isn't a tornado outbreak. It's an extremely cold weather event that impacted Texas back in February of 2021. Researchers, practitioners, planners, insurance professionals, energy grid operators, landscapers, homeowners, and many other people have wanted to know more about how these extreme cold weather outbreaks work so they can better mitigate against the impacts and better plan for their arrival. The search for these answers led us to Dr. Cohen, who will explain more of the big picture behind these extreme weather events and the science in their prediction. A more formal introduction of this week's guest, Dr. Cohen is a visiting scientist at MIT's Parsons Lab, which is part of the Civil and Environmental Engineering Department. His main position is Director of Seasonal Forecasting at AER, or Atmospheric and Environmental Research. He's currently working on the impacts of snow cover and sea ice variability on winter climate. He's also interested in accelerated Arctic warming and its influence on extreme mid-latitude weather, and applying novel statistical techniques to subseasonal and seasonal weather prediction. Another of his interests is researching decadal temperature trends and explaining these trends with large-scale climate models. He received his PhD from Columbia University and was also a postdoc at the NASA Goddard Institute for Space Studies. On Dr. Cohen's website, the banner reads, "Unique Winter Season Forecast based on Siberian snow cover. Most accurate model to date." We'll unpack what all that means in this podcast episode with Dr. Cohen. Judah, thank you so much for taking time to come on the GeoTrek podcast.
My pleasure.
Judah, you've been researching Arctic outbreaks for a long time. I mean, what are you looking for in that type of research? What kind of relationships climatologically are you looking for?
Yeah, I don't know if I would describe it as Arctic outbreaks. I'm involved with seasonal forecasting, and I'm trying to make a seasonal forecast. So I'm really more interested in, will the winter be, colder than normal, be milder than normal? Try to throw in snowfall in there, though that's really difficult.
Sure.
And I feel like that's more for entertainment purposes than real rigorous science. But obviously, Arctic out, 1-2 Arctic outbreaks of winter can make the difference in how the season, averages come out. So
sure.
I think in the winter of 2020-21, we had that historic outbreak in February, and that pretty much tilted what was previously up till then a mild winter into a cold winter, at least for the Central U.S. So, and obviously there was a lot of impact to the energy infrastructure and
sure.
Unfortunate casualties, fatalities. So I mean, so one Arctic outbreak can be very, can really be very important for the seasonal mean.
Yeah, Judah, I live in Southeast Texas. We were highly impacted by that. We lost power for 3 or 4 days, and a lot of these homes are elevated without much insulation, so you could quickly get your home temperature down near or below freezing. Like you said, there were fatalities, so people now are really on edge. They're wondering, kind of looking over their shoulder to our north, saying, is something else like that coming,
Right, yeah.
So what are some of the forcing mechanisms here? Like you talked about that February 2021 event. I mean, what really drives an event like that to push cold air that far south?
Yes. So I've been proposing this idea that, well, I mean, I would say it has to do with the polar vortex. I don't really get much pushback, but maybe some people say I overemphasize the importance of the polar vortex, but I think it's very difficult to get severe winter weather without some kind of involvement of the polar vortex. So the polar vortex, in its normal state, is an area of low pressure that sits right on top of the North Pole. If you think of the atmosphere having two layers, you have a bottom layer is the troposphere, that's where we live, the weather occurs, that's where the jet stream is that move the weather systems along, and then above that is a top layer, the stratosphere, and that's where the polar vortex is.
Okay.
So it's an area of low pressure, sits right on top of the North Pole, and like all areas of low pressure in the Northern Hemisphere, it has a circulation, this river of air around it that circulates from west to east.
Sure.
The polar vortex, the configuration of it, the shape is very circular, and the coldest air of the Northern Hemisphere contained inside of that circulation, on the poleward side. So if it's nice and circular in shape, the cold air is bottled up very close to the North Pole. And at times, though, and if you think of I like to give the analogy of the polar vortex as a spinning top. In its normal state, it's this fast spinning, very quiet rotation.
Sure.
And all the cold air is kept close to the center of rotation. But at times, the polar vortex can become disrupted or weakened. So it'd be like that top, banging into something. And so it starts to wobble, and it slows down, and it starts to wobble and meander. And also, if you think of like an ice skater, when the ice skater is a nice tight rotation, have the arms close to the chest, it's, the ice skater stumbles and the arms start flailing out.
Sure.
Same with the cold air that's associated with the polar vortex, is it kind of extends out from the center of rotation. So it will go much further south than normal, and then that's when we get these cold air outbreaks.
When that happens, is that called a weakening, or is there an index with it? How do we refer to that?
Disruption, a polar vortex disruption, or a weakening. So you have a strong and, so people thought of the polar vortex kind of binary. It was strong and weak. So when it's strong, we tend to be mild. So late December, early January, the polar vortex got strong. We had mild weather. Before that, it was weakened and disrupted. We had that cold air outbreak there at mid to late December. Now there are signs that the polar vortex is weakening again.
So that could push more cold air down through southern Canada and into the continental U.S.
Yeah. So, typically the cold air moves east of the Rockies. The central U.S., I think, seems to be the area that is most, so there are two flavors of, main flavors, I'd say, polar vortex disruption. So there's a very large one that is called sun stratospheric warming, because there's a very dramatic warming over the North Pole in the stratosphere, polar stratosphere. But the temperature could, rise within a week of over 100 degrees Fahrenheit, something that would, not happen at the surface. That's the one that's been most studied. And the polar vortex, when it gets this very large disruptions, these sun stratospheric warmings, you can have either a displacement where the polar vortex stays, integrally whole, but gets moved quite a bit off the North Pole. It can typically moves into the Eurasian continent. And there's also times where it kind of breaks into pieces.
Okay.
Called the polar vortex split. At least if you're looking at animations of polar vortex, that's the most dramatic. But that's the one that's been studied. I'd say like 99.9% of the scientific literature has been on these very large disruptions. But then recently I've been looking at this more minor disruption where the polar vortex kind of stretches out, it elongates.
Okay.
It's like pulling on a rubber band, right? So if it's nice and circular when it's strong, and all of a sudden it gets kind of pulled, like pulling at two ends of a rubber band. And But what's important about these events, they're minor, so I think people ignore them. But it turns out they have the biggest impact. The severe winter weather is more in the U.S. is more closely associated with this polar vortex stretching than these much larger events that are called sun stratospheric warmings. Where really the impacts are focused across Eurasia and not so much North America.
So with the stretching, the elongation, that's where we could more often see some of this cold air coming down into the continents.
So like February 2021, where they had that was a kind of this stretching or elongation. This past December event that was very severe, in Buffalo, I guess got the worst of it. That was also a stretching event. It looks like another stretching event is coming up, is beginning now, and will kind of start to impact our weather at the end of the month.
If you were to draw a map of these stretching events, is some of the territory still kind of circumnavigating the North Pole, or does it actually?
Right. So if you think of if the shape of the polar vortex is circular, right, and the winds are circulating around it, then our flow is west to east, across the U.S. So that means the source of the air is off the North Pacific, which is relatively mild, right, compared to the continents. But what happens if it becomes stretched out? It's like this oblong, straight, a hot dog shape or something. But now the flow is not west-east anymore, right? Because if you can try a picture, it's now north to south.
Sure.
So the source of our air changes dramatically. So instead of coming off the North Pacific, and that's why California right now is getting this fire hose of precipitation. Sure. Because that the air is flowing in a straight line off the North Pacific, and they're just getting slammed with all this moisture.
Yeah.
But then, as it comes down the Rockies, it warms up a lot, so we turn very mild. Sure. But now, if you get this kind of elongated, oblong shape to it, the wind is not coming from the west, from west to east, it's flowing north to south. So it's pulling cold air out of Canada. Sure. And even in the most extreme event, it's pulling air out of Siberia, which has the coldest air in the northern hemisphere. I think that's what happened in December, where it tapped into some Siberian air. And that's why it was so extreme. The cold was so extreme. Really,
I used to live in Fairbanks, Alaska, and I noticed about a week before the really cold air hit the Central and Eastern U.S., the temperatures in Fairbanks. I mean, they were getting high temperatures. I think minus 36, things like that. I mean, it was really frigid up there, and I think moving, to the south and east.
Yeah. So you will see that ahead of these events, you'll see cold air start building up in Alaska and northwest Canada. It's kind of...
And then it's on the move, right?
Yeah. So that's typically... Yeah. So the cold air, it doesn't just appear. It tends to kind of source or pool. Sure. And then it gets pulled, and then it taps, the jet stream taps into it and pulls it south and east.
Judah, what models do you look at if you're trying to get an idea, like, will there be another outbreak this winter? I mean, where do you look for that kind of information?
Well... we have weather models, so all the large countries have, their own weather model. There's a U.S. weather model. There's a Canadian one, but the one that's considered the best in the world is the European one. And maybe you'll hear about it on the news, like especially with hurricanes. They'll show you, the American model shows this track for hurricanes, sure. The European shows that. So, that's good up to 2 weeks, and they're good for a week. There's been tremendous advancement made there with the models, but I do think they suffer from not coupling correctly what triggers these polar vortex disruptions, and then once you get a polar vortex disruption, how does that translate into our weather? So I do try to get ahead of the models and anticipating. So like for now, for example, so they're showing this polar vortex disruption, a stretching. It could be more, but for now it's definitely a stretch. They're not showing. I haven't looked this morning. Sure. The weather was not, it was relatively benign. It was like, it's been pretty mild. It's supposed to get close to seasonable, but I do think it's gotten super cold in Siberia. Sure. Minus 80 degrees Fahrenheit. Like really cold. The cold we don't see even in, Alaska doesn't get that cold. So, I think when it gets really cold in Siberia, I guess the first place you got to look for risk of really extreme cold is East Asia, into China. And I think they are predicting some severe winter weather there. But I think it's also could be for us as well. Typically, it hits Asia first and then comes to us.
So you'll kind of look at East Asia, Siberia, China, Mongolia, and kind of see what's happening there because they're upstream.
Siberia is the key. I like to say Siberia is the refrigerator of the northern hemisphere. Sure. So watch Siberia. So Siberia turned really cold in December, and I thought, okay, that's like that's a kind of warning shot that the Asia and U.S. were under risk for extreme cold. And then it got really mild in December, and in Siberia, mid to late December. I said, okay, that mild weather's coming, and and that worked very well. And then Siberia's turned much colder now. Okay. I have this rule of thumb: when Siberia turns cold, maybe 2 weeks later it turns colder here. So
sure. So it's going to basically travel through Alaska, Western Canada, and then be on the move towards the Central and Eastern U.S.
Not all the time it gets, the Siberian ear gets tapped. It's called the Siberian Express here in the U.S. Sometimes I've heard that TV mirror. And not always that happens, but I certainly think there's at least some of that air could make its way, probably into maybe early February.
Sure. Judah, do you see trends with this long-term impacts of climate change, or are these outbreaks really a part of natural variability from what you're seeing?
Yeah. So great question. So this is an ongoing debate. Most of my colleagues say, whatever we see with the winter weather, it's natural variability. I argue, there's a minority of us that argue that we see the impact of or the contribution of climate change. So so these stretching events. So we had a paper where we argued that these polar vortex stretching events are occurring more often, over the past 40 years. You could see an increasing trend. And the reason for this trend is not natural variability or random or chance, but rather it's because the way things are changing in the Arctic, that they have favored the way just by whatever, I don't know, for whatever reason, just the way the juxtaposition of those changes favors more disruptions of the polar vortex. And, it's a little bit complicated, but I'm happy to try to get into that and explain that to you.
For example, the Arctic being more ice-free. I mean, does that play into this?
Yeah. So there are two important components. One is sea ice melt. I mean, I think that's the one change in the Arctic that people most closely associate with Arctic change or climate change. But the sea ice melt isn't uniform or homogeneous. It's actually happening in focused regions, and that's really important for the idea that I propose. A proponent of advocating. It's melting quick in the fall and winter months. It's melting quickest across near northwest Eurasia, so near Scandinavia and northwest Russia. It's called the Barents Kara Sea. So it's so that's where the region we're seeing the fastest sea ice melt. So there's a kind of bullseye of heating right in that region because they're losing the ice the fastest. When you expose ice is a good thermal insulator. So it prevents heat in the ocean, which heat's a huge reservoir of heat, from escaping from the ocean into the atmosphere when you have a layer of ice. You peel that ice back. And
you're like capping that energy, right?
Yeah, all of a sudden that energy. If you go to these geothermal, springs or whatever, and you go there in the winter and it's really hot, and you see all the steam coming out. So that happens, over the Arctic Ocean when you melt the ice. But I mentioned Siberia, but the other key part of it is that there's more snowfall now in Siberia because a warmer atmosphere holds more moisture. Okay. Siberia is super cold. They're really moisture starved. It's, the snow there is not limited by temperatures. It's limited by moisture. Now you're getting the atmosphere is moistening. Also, I think you're getting kind of a lake effect because
more open water kind of thing.
Yeah, because and then same thing happens in the U.S. So like with Lake Erie, right?
Sure.
The beginning of the winter, it's ice freeze. That's when Buffalo typically gets their big lake effect events like we saw this year. But then it freezes and then the lake effect machine shuts down. There it's in reverse. It used to be always ice in the Arctic Ocean, so there was no lake effect. But now as it melts, there's more and more lake effect. That's an idea. It makes sense, but I haven't really.
How do you think increasing the snowpack in eastern Russia might affect circulation or the regional and international weather patterns?
So I think that they're like a couple. The melting ice to the west, right near Scandinavia, heats the atmosphere, and then to the east you have more snow, and snow has very high reflectivity. It's the most reflective naturally occurring surface, so incoming sunlight gets reflected back out into space, but also, like the ice, it's a good thermal insulator. So not only can heat escape from the ocean, it can actually escape from the ground into the atmosphere. You put snow down and shuts that down. Also, at night, we lose energy to space. Well,
Yeah.
and the Earth is giving off energy all the time, just like the sun. But at night, it's losing. There's no incoming solar. That's why we get colder. Snow is very efficient at emitting or giving off this energy.
Sure, the radiation. What's interesting as I hear you talk about this, it seems quite complex. Where perhaps in the north of Siberia over the water, you may have a warmer atmosphere because you have ice free, but then perhaps over parts of Siberia and eastern Russia, it actually might be colder, like at night, because you have more snowpack that's helping radiate this energy out. It seems like it could really change around.
You actually see that in the temperature trend. So. Right along the coastline of Siberia, you see a warming trend. But as you head further south,
it might be a cooling trend.
There's a cooling trend, yeah.
No, that's really interesting. And I used to give a science talk at University of Alaska. I was there for a couple of years, and a lot of tourists would come into and just the complex nature and a lot of what's happening in Siberia and eastern Russia does come over to Alaska. The scientists there said actually during like the Soviet Union, they were getting these great data from eastern Russia, and then I think like in the 90s with the transition politically, a lot of these data started drying up, and Alaskan researchers said, we really need to know what's happening upstream in Siberia to forecast our weather here, so just interesting how it's all connected.
Yeah, I mean, when I first was, again, arguing for these ideas, it was very counterintuitive because, again, like I was mentioning with the polar vortex that flows from west to east, typically weather system move west to east, so we don't think of, I was saying Siberia is impacting our weather in the U.S., but it's not, our weather's coming from the West Coast and then the Pacific. People couldn't understand why are you saying Siberia could impact our weather? How does it get here? But I think maybe people appreciate more and more that how everything is interconnected. And because Eurasia is such a big landmass, it really is very important. It's definitely very important for driving the behavior of the polar vortex. And certainly, if you then agree that the polar vortex influences our weather, then it's easy to make that connection. But
Judah, were you saying when the stratosphere warms up over, so this is obviously the layer above the troposphere, when it warms up over the polar vortex area, that can get these tropospheric, cooling to kind of be on the move and elongate more? Is that true?
Yeah, so what happens is, the reason I don't think we fully understand, but what happens first with the polar vortex and the stratosphere, then will happen about 2 weeks later in the troposphere. So when you get these big disruptions of the polar vortex, what's called the sun stratospheric warming, you have this very strong warming over the Arctic, this big high pressure that forms over the Arctic, and the cold air and the low pressure gets displaced much further south. And that kind of ribbon of air that's associated with the polar vortex gets pushed also much further south. And then 2 weeks later, we see the same thing happening, in the troposphere.
Okay.
The jet stream, you get this, it gets warm over the Arctic, you get big high pressure over the north, somewhere over the Arctic near the North Pole. And the cold air that was previously over the Arctic gets displaced south. You kind of get lower pressure into the in the mid latitudes, and the jet stream is displaced equatorward or southward. Okay. So it first happens in the stratosphere, and then it happens in the troposphere 2 weeks later. Again, I don't think we fully understand why. But again, even if it's a coincidental, kind of connection there, I would say it's random, it's not physical, but it can be used to make, these longer range forecasts, because we kind of know, we see this big change in the stratosphere, it's coming to the troposphere as well.
That's really interesting. And when it's on the move, it sounds like high pressure builds over the Arctic Ocean, and you get low pressure moving down through Canada and the continental U.S., bringing this really cold air with it.
Cold, yeah, right. Those storms bring the cold air with it, and it can also increases the chance of getting a snowstorm. Because if the storm track, those areas of low pressure that are moving along the jet stream are further south, if you're on the north side of that, those moving storms, you're more likely to get snow. Whereas if it's much further north into like Canada or something, then you're going to get rain from those.
So this is really a displacement of the jet stream, and like you're saying, storms can track along that. You could potentially get some big snow producers.
Yeah.
Judah, really appreciate you coming on the podcast. How can our listeners find you, your research? I don't know, are you on social media or just different journals or different platforms?
Okay, so I write journal articles, but I'm active on Twitter at at Judah47. Not the greatest handle there. If I'd known I'd be so active on Twitter, I might have been.
And that's JUDAH 47?
AUDAH 47.
Okay.
I also have a blog. I have a weather blog where I try to make these longer range forecasts. So in the winter months, it's every week.
Yeah, I mean, I checked you out on Twitter this week, and I thought it was really useful stuff. You were just giving snapshots of what might be coming down the road. And I know for our listeners on the Gulf Coast, they're worried about freezes. I know for some friends of mine that work in like the ski industry in the Northeast, they're having a rough season, and they're all wondering, is cold air going to come back? I mean, the type of stuff you're putting out with these, looking mid to long range, I think a lot of people would be interested to see that.
Thanks. I mean, I think there's an interest there. But so if you do Judah, if you blog, if you search, Google search Judah Cohen blog, it'll be like the first thing that comes up. It's called the Arctic Oscillation Polar Vortex blog, but it should be easy enough to search and find. And so every week there's an update to it. It's made public on Wednesdays. On Monday, you have to pay a little bit to see it in advance, but on Wednesday it's open, it's free to the public and anybody can read it.
Judah, in the beginning of our conversation, you said you do a lot of seasonal forecasting. Do you forecast as well for like summer events, for tropical events, or is most of your focus really winter events?
Yeah. I mean, we make seasonal forecasts all year long.
Okay.
So, I mean, spring, summer, fall, winter. I mean, I'm just best known for the winter.
Sure.
I think the winter is much more challenging. To be honest, summer's gotten less interesting because there's been this just basically monotonic warming trend.
Sure.
In winter, it's been more complex. And I think the polar vortex has made that warming more complicated. It hasn't been like a straight line warm. I think we're getting...
Yeah, and it seems like we have more of a gradient in the winter, right, across the hemisphere. Like in the summer, the temperature difference, say, between northern Canada and the Gulf Coast, it tends to be less, I guess, in general than in the wintertime, right?
Yeah, that's absolutely true. And that's why the jet stream is stronger in the winter. It's also further south. But yeah, I mean, so.
Yeah, Judah, thank you so much for coming on the podcast. We'll make sure that we follow you online, and best wishes for you and your research.
Oh, thank you. I really appreciate that.
Thanks, Judah, for sharing your insights about the science behind these severe weather outbreaks. I really like how you describe Siberia as the refrigerator of the Northern Hemisphere. It's important for our listeners to understand that this very cold air does not simply just show up in a place like Chicago. It has a source region and then a long distance to travel before inflicting its impacts on the Central and Eastern U.S. Some very cold air can also be sourced from places like interior Alaska and Canada's Yukon territories as well. And I wanted to get someone on the podcast who could share a firsthand experience about living in such extreme cold. I couldn't think of anyone better than science writer and adventurer Ned Roselle, who has lived for more than 35 years in interior Alaska and was the star of GeoTrek podcast number 3. Ned is a close friend of mine and happened to be visiting me in Galveston this week, so we recorded this segment live at my home in Galveston, Texas. Ned, thank you so much for taking time to come back on the GeoTrek podcast.
Thank you, Hal.
Ned, we're talking about these cold Arctic weather outbreaks in the lower 48, and what we're hearing is a lot of this polar air, this Arctic air, is originating in northern Canada and Alaska and Siberia, and then it's on the move down to the lower 48. You've lived in Alaska more than 35 years. You've experienced a lot of this tremendous cold. What's the coldest temperature that you've lived through?
Minus 57 Fahrenheit.
Wow. Minus 57, so that's 89 degrees below freezing. I mean, what is it like to experience a temperature like that?
Yeah, well, you're sort of confined to the indoors because at those temperatures, your flesh will freeze and you'll lose fingers and limbs if you're out in it too long. But nobody usually dies in Alaska because we all have these great adaptations of buildings and great clothes, and believe it or not, cars will still run at that temperature if you've sort of preheated the oil and or have a garage.
So you're plugging the cars in, right?
Yeah, cars that are not garage, and mine never have been, up there in Fairbanks, Alaska, the middle of Alaska, have what we call frost plug heaters, and it's basically a heating element that you put. It's in contact with your coolant, just sticks out there like a tongue, and you plug in, and that keeps your coolant a bit warmer. So it sort of pre-warms the engine when it's real cold, say we usually plug in at like 0 degrees Fahrenheit or colder.
Yeah, it's amazing. It's amazing, too, to see shopping centers, universities, see parking lots adapted with all these plugs, right?
Yeah, you have these posts out in every parking lot, and they have an outlet on them. So, yeah, if you wanted to plug in your TV there, you could watch it. But mostly it's for, to plug in these frost plug heaters on your car, and we also have battery blankets or just a heat pad that your battery sits on that sort of keeps it a little warmer than the air temperature. Don't
car tires start kind of not getting round at a certain temperature as well? They start kind of squaring off a little bit?
Yeah, I don't know if new tire technology has improved, or if it hasn't been that cold recently, which is also a possibility. But yeah, back in the day, you'd leave your car parked, say at minus 40, and then when you got going again, if they weren't totally inflated, there'd be a flat spot where the car was sitting, putting all its weight on it. So you'd hear this rhythmic thunk for a while. It would go away after a few hundred yards, but it was always a little unnerving.
Yeah, the physics of things seem to change a little bit when you're in really extreme cold.
Yeah, there's a lot of things we notice, like sound waves really propagate well for some reason. Like you could hear a train from miles away, and it sounds like it's coming down your street. And airplanes sound kind of different, really loud as they're going overhead. Yeah, but amazingly, things sort of work at that temperature. Yeah, light bulbs work. Outside dogs still bark. And cars roll along if they've been treated right.
Yeah, it seems like society's adapted for it, right? Like you said, you're not having a lot of fatalities and these extreme cold events. It seems like interior Alaska is prepared for them.
Yeah, we have what would be considered super insulated houses, like compared to here. We still have some gaps and stuff, at least in my house. But yeah, I noticed we haven't been above zero, like it's now January. We haven't had above freezing temperatures since probably October. Yeah, mid-October.
And that's pretty common that the interior could go really from mid-October until maybe mid-March without getting above freezing?
Yeah, that's exactly right, Hal. Yeah, so that's a long period with up cold.
And that's a big difference, I think, from almost anywhere in the lower 48. Even you go to places like Minnesota, right? They'll often say, we're the icebox of the country. And they'll get to sometimes 30 below, 40 below. But then the next week, they're up in the low 40s above or 50 above, right? In interior Alaska, you don't really get the breaks like that sometimes.
Yeah, it's fairly constant up there, which we like for our snowpack. Like we get snow in November often, and we can ski and ride our snowbikes on that snowmobile for months. Yeah.
Yeah, it really stays a long time. Ned, in this podcast, Judah Cohen was talking about these Arctic outbreaks that, really the source regions are up there closer to the Arctic. Once the air starts on the move, we get a really strong cold front. It's related with the Polar Vortex. And all of a sudden we get these blasts that come down, often with very stormy, windy weather, even blizzard conditions like we've recently seen in western New York. So the cold air's on the move. It shows up with really strong winds and things like that. But we know, like you've explained to me, in interior Alaska, in these places, these source regions, sometimes when you get the really cold air, there's actually no wind at all. Describe for me the typical conditions when you're really getting that cold air. I mean, what's it like? What do the skies look like? What does it feel like? Do you have any wind?
Yeah, we often have no wind. We live in Fairbanks, Alaska is a very windless place because it's got like these hills on three sides that shade us from wind. And wind causes mixing, and we have what we call temperature inversions, where the air is so stagnant and non-moving in the bowl where we live that after a while this sets up where low parts like stream beds and bottom of the valleys can be 40 below, and then you go on top of a 2,000-foot hill nearby. You go from 40 below on the lowlands to, maybe plus 10 or something. So these really extreme temperature gradient setup when there's no wind. And when it does come, we'll mix that up and warm things up on the surface.
And a lot of times there's a lot of ice fog as well, right? When we're in these temperature inversions, the cold air, it's very dense, it's down low. And a lot of times you have this layer of ice fog down in the valleys as well, right?
Yeah, Fairbanks is one of the only towns in the U.S. where ice fog is occasionally part of the forecast. And what it is just water vapor that... what it is water vapor that can't be sort of dissipated because it's so cold. So it just kind of hangs in the air like cotton candy. And that happens it doesn't happen often these days because we're getting warmer, but it happens at like minus 35 when the air temperature reaches that. Then you'll notice, a car going by and its exhaust just hangs there like it's a solid, this solid streamer of white. And that all adds up because we have this sort of windless condition in our town, and it kind of, fills up that box after a while. So all the water vapor, including open water sources like our river going through town, it's open because we have a power plant that uses the river for cooling, and it warms up the river somewhat. So it's not all iced over. There's little parts that are open, and there's a lot of steam coming off that. And one researcher in his classic paper on ice fog, he even calculated how many dogs Fairbanks had, like 2,000 dogs back then, and he counted their exhalations, the water vapor that came out of the dog's mouths, as part of his calculation for this low visibility problem.
Yeah, any moisture, right? It's crystallizing into ice crystals, and it's just hanging there. And for our listeners, it's, again, you have hillsides around Fairbanks and places like that, but when you come off the hillside, you go into the valley, all of a sudden you're in this very, very dense crystal-like ice fog. It's very dense, and again, there's no wind, there's no mixing, and it's very cold in the valley bottoms.
Yeah, and cars produce that too, because one of the byproducts of burning gasoline is water, and that comes out of the tailpipe. And when it's that cold, it just sort of
you see kind of this cloud behind the cars, right?
Mm-hmm.
Really. The other thing too, you mentioned 35 below. What might really surprise our listeners is that could be the low temperature to start the day, and then in the afternoon you might not be that far still from 35 below, right? You're not really seeing a temperature change day and night in some of these events.
Yeah, because Fairbanks is so far north, we're about 120 miles south of the Arctic Circle, that the sun doesn't really have much punch because we lean so far away from it this time of year during winter that, you can't feel it on your cheek, even if it's a sunny day and it's midday. And, really, if you watch your temperature graph, there's not much of a sawtooth in midwinter. It's just sort of flatlining, and it's being affected by things other than the sun.
Yeah, that's right. That's a good point, right? You could be 35 below in the day, and then at night, if you get a little bit of wind or some clouds move in, all of a sudden you could go up 15, 20 degrees at night, right? So it's not really following the normal pattern of sun and dark, right?
Right. It will in sort of mid-February. You start getting that. The sun has a little more punch, and then it has a lot more punch, into March and April. But right now is a dark, quiet time up there.
Ned, thanks for coming on the podcast, explaining what it's like. A lot of our listeners have never experienced that type of extreme cold, and it's interesting because we're seeing the effects of that. We're seeing some of those air masses more and more moving down to the lower 48 states, impacting the Central and Eastern U.S. But it's kind of interesting to hear from someone who lives in one of the source regions where this cold air is coming from, and just to hear what that's like.
Yeah, well, I'm glad to be visiting you down here in the South for a little break from that.
We're recording this in my place in Galveston, Texas. Ned came down for a week to see some sunshine, warm up a little bit. It's that time of the year where you can be below freezing, really below zero for many days in a row up in Fairbanks. So great to have you here. Hopefully you're thawing out and enjoying the visit.
Yes, I am. Thanks, Hal.
Thanks so much, Judah and Ned, for coming on the GeoTrek podcast. Here are the main points I got from these interviews on this podcast episode. Number one, the polar vortex is a large area of low pressure and cold temperatures surrounding the poles. When the polar vortex is strong, the air remains bottled up at high latitudes and the jet stream stays really tighter. When it weakens, the jet stream can dip considerably and cold air drives far to the south, bringing impacts to places like the southern part of Canada and the continental U.S. Number two, Dr. Cohen was sharing that there are different kinds of polar vortex displacements. The one with the biggest impact on the U.S. is an elongation of the polar vortex, as the boundary of this area stretches far to the south of its normal territory. Number three, I thought it was really interesting how Dr. Cohen talked about how interconnected these climate patterns are. When we discussed the impact of climate change, he pointed out that the Arctic climate is not changing in a uniform way. One of the areas that has observed substantial loss of sea ice is the Barents and Kara Sea region of the Arctic Ocean basin, north and east of Scandinavia and off the coast of northwest Russia. He pointed out how open water in this region is increasing snowfall in Siberia, which can lead to colder temperatures in the continental part of Siberia. This has large implications for the northern hemisphere. Dr. Cohen stated that Siberia is the refrigerator of the northern hemisphere, and warmer cold patterns in that region often precede what's happening in the central and eastern U.S. by around 2 weeks. This is a good reminder of how interconnected the climate is. Number four, Ned Roselle's account of what it's like to live in one of these source regions of extreme cold was interesting and eye-opening, as he described a world that few of us could imagine. In his world in interior Alaska, the temperature might stay locked at 36 degrees below zero Fahrenheit night and day in a strong temperature inversion. Visibility in the valleys can fall to near zero on these days as ice fog blankets the region. He also described pictures of people plugging in their vehicles so they'll start when they're living in such extreme cold. So again, really dramatic cold that a lot of us, for example, in the lower 48 states have never really experienced before. The good news of these extreme Arctic outbreaks that reach the central and eastern U.S. is that the cold weather moves from source regions like Siberia, Alaska, the Canadian Yukon, and then moves as an air mass to the south and east. This enables weather models to predict their arrival and gives ample warning to people in harm's way. Take the Christmas 2022 Arctic outbreak in central and eastern U.S. Although extreme cold did not really show up in Alaska's north and west coast with that event, it did show up in Fairbanks, where Ned Roselle lives, as the temperature was at least 20 degrees colder than normal for 5 consecutive days. As the air mass moved east, it intensified, with Tok, Alaska, near the Canadian border, experiencing temperatures at least 33 degrees below normal for 5 days straight. Then we all followed this extremely cold air as it barreled through many Canadian provinces and slammed the northern Rockies and the plain states of the U.S. As the air mass was on the move, winds picked up, and it became a formidable winter weather event, packing strong winds, very cold temperatures, and blizzard conditions. Number five, finally, as research evolves on this topic, you can follow mid and long-term forecasts from Judah Cohen. You can find him on Twitter at Judah47, or just do a web search for Judah Cohen blog. These forecasts are updated weekly, and again, they're giving projections of what we can expect looking down the road as far as the next really Arctic outbreak getting into the continental U.S. Special thanks to Judah and Ned for coming on this podcast about extreme cold. It's a topic that's highly relevant for people from the Arctic and subarctic all the way down to the subtropics, where freezing temperatures can inflict impacts all the way, for example, along the U.S. Gulf Coast. Finally, as research evolves on this topic, you can follow mid and long-term forecasts from Judah Cohen. You can find him on Twitter. His handle is at Judah47, or just do a web search for Judah Cohen blog. The forecasts are updated weekly. And again, what he's doing here is pretty unique. He's looking really upstream and really focusing a lot on what's happening in Siberia. Again, what's happening there may impact the central and eastern U.S. 2 weeks later. And again, to reiterate some of these connections, he's finding that having more open water in the Arctic Ocean and in the Barents and Kara Sea, again, northeast of Scandinavia there, can increase moisture in Siberia. We often think of snow happening when it's cold, but in Siberia, it's plenty cold to get snow anytime. historically, snow has been limited by not having enough moisture. With the more open water because of melting sea ice, we're seeing more snow in Siberia, and snow actually really cools the climate for two reasons. He explained the reflectivity of snow. When we have incoming sunlight, it can reflect a lot of that sunlight, a lot of that solar energy, and also Earth is always radiating heat. And so when you have snowpack at night, you can really radiate heat more efficiently. And so more open water in the Arctic and in the Kara and Barents Sea. We're seeing more snow in Siberia. More snow in Siberia, the temperatures are colder, and that really is upstream from what's happening and what's coming into North America. It's fascinating how all these things connect. That's what Dr. Cohen is doing in his research and his blogging. And again, you can find him on Twitter and on his blog to see really what's happening and to see a forecast and get a snapshot of what we might expect down the road. Special thanks to Judah and Ned for coming on this podcast episode about extreme cold. It's a topic that's highly relevant for people from the Arctic and subarctic all the way to the subtropics. That's right, all along, for example, the I-10 corridor of the U.S. Gulf Coast. We've seen big freezes in recent years as far south as the Gulf Coast, and people even there are very concerned about cold weather outbreaks. I'd like to thank our marketing team as well for their help disseminating each podcast episode. Our team is Senneth Baker, Ashley Anderson, Jeremiah Long, Christopher Cook, Amy Wilkins, and Courtney Booker. And of course, a huge thank you to all of our faithful listeners for your interest in this podcast. Stay warm, everybody, as we push through these remaining weeks and months of winter. We're kind of getting into the second half now. I'm Dr. Hal, and I'll catch you on the next episode of the GeoTrek podcast.